Okay. Good morning, everyone. Okay, so what we're doing today is we're going to finish up a little bit of stuff that on Vertex stuff. Okay, we're going to start off kind of with a globy kind of look, all right? But I'm going to take you through a few pages that are in Vertex, page 602 and 603. Okay, and it turns out that page 602 and 603 has a ton. I might have given you those pages earlier on. I didn't give them to you today. Okay, but page 602 and 603 in Vertex has got tons of information about great circles and rhumb lines. In particular, when you should do a great circle versus a rhumb line, and then also this thing called composite sailing, and then intermediate points and yada, 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 yada. Okay? And there are going to be a ton of nav general. There's quite a few. There's like 100 nav general questions in the question bank. They're around these types of things. So what we're going to do today is we're going to talk a little about the Vertex. I got to wrap up a little Vertex thing that I didn't get to last class. All right. We're going to talk about rhumb lines and great circles. And then we're going to do some composite sailing, which is going to bring us to the handouts and the charts. Okay. So, okay. So, this is page 602. I think it's 602. All right. Rhumb lines. Okay. Well, I got to use the pointer because, you know, it's last, anyway. Yeah, okay. Rhumb lines. Principle. Oh, where's my pointer? Oh, here it is. Okay. Where's my laser pointer? Oh, you bastard. You bastard. Already the problems have already started. I can't see my mouse. Where is it? Here it is. Screen. Where, pointer options? Is that pointer options right there? Yeah. Okay. Okay, great. The principal advantage of a rhumb line is that it maintains a constant true direction. Okay? So, right? When we're on a Mercator chart, okay, we're on a Mercator chart, okay? All right? Whatever. Okay? You cross all the meridians at the same angle. All right? That's beautiful. You never have to change course, assuming there's no current or leeway. Okay? And your helmsman isn't pooching it. All right? You just steer that course, eventually you're going to get there. But it turns out that's not usually the shortest distance. But that's the beauty of it. Okay? You set it and forget it. No, not exactly. Don't forget it. Okay? You got to monitor your voyage plan. A ship following a rhumb line between two places does not change true course. Damn. A rhumb line makes the same angle with all meridians as it crosses. It appears as a straight line on a Mercator chart. Okay? It is adequate for most purposes of navigation. It's also adequate for bearing lines, except long ones as obtained by radio. Let's not even worry about that because we don't use that anymore. And course lines both being plotted on a Mercator chart as rhumb lines, except in high latitudes. So it says in high latitudes, it's really not the best. Okay? The equator, move. The equator and meridians are great circles, but may be considered special cases as a rhumb line. Okay, what's one of the definitions of a rhumb line? As you proceed along it, you cross the meridian at the same angle. Okay, so here you go. Here's the equator. Equator's a great circle, right? Great circle? A great circle bisects the earth. Cuts it in half. Okay, so that's a great circle, wherever that equator. But here you go. Justin, I'm going that way. What's my course? 090. I crossed another meridian. What's my course? 090. I crossed another meridian. What's my course? I crossed another meridian. What's my, yeah, zero. Oh yeah, it's a freaking great circle and a freaking rhumb line. Cool. How about this way? Oh, 270. Good. Okay. Hey, Gabriel, I'm going north. What's my course? 000. Yeah. It's not a trick question. What's my course, Gabriel?
0.
What's my course, Gabriel?
Same thing.
What's my course?
Same.
What's my course? How about now? 180. Oh, crap! As I'm going along the meridian, I got the same course the whole time. Damn! When I'm on a meridian, or I'm on a equator, I'm on a great circle, And it's also a special case rhumb line. But Tyler Hall in the back, if I start going at some cattywampus angle, okay, not going north, not going east on the equator, okay, then things start to get a little peculiar. I'm going to have a great circle and a rhumb line. They'll be two different things. Okay, so look, great circle. Okay, great circle. If you want to do a great circle, you're going to start off on a mnemonic chart, which we're going to go to in a minute. Okay, one of the interesting things about mnemonic charts is that the equator is a straight line and the meridians are all straight lines. Okay, but meridians start to look something like this. Okay, meridians start to look something like this. And then the parallels are actually curved. Okay, so if you look at your mnemonic chart, you'll see this pattern. Okay? Whereas on the Mercator chart, we got that. Okay? So, cool. So, when we're laying out a voyage, okay? Like, you know, maybe we'll do a great circle. Maybe we'll say we'll go from here over to there. Okay? That's a straight line on the earth. What if I told you that this was 45 degrees north and this was 50 degrees north? This line here is 45 degrees north. This line here is 50 degrees north. Rebecca, what's my latitude when I start? I start here, I end there. What's my latitude when I start? 45. What's my latitude in the middle? Yeah, my latitude freaking changed. I went north. Okay? And then what's my latitude at the end again? Oh, so my latitude changed. Okay, check this out. This is north. So 90 degrees is something like that. What's my course? When I start off, what's my course? That's north, that's 90. So it's like 90 plus maybe 30, 40, 50. Oh, that's interesting. I'm kind of going, well, you know, well, actually my course is all the way around to here, actually. Sorry about that. My course is all the way around to here. So I'm steering like something north of 270. Nick Lewis, what's my course right here when I'm at the highest latitude? What's my course right there? Right there. Yeah. Why did I put that little freaking thing, the upside down L? Think about trig.
Right angle.
It's a right angle. What's my course when first of all, what's the fancy name for this special spot, the maximum latitude? Vertex. What's my course at the vertex? 270. At the vertex, I'm either going due east or due west. What's my course back when I get all the way over here, though? Well, here's 270 there. See, it's kind of weird. The chart's kind of weird because the lines are all at different angles. So you got to like kind of look in there. But now my course is southwest. I was going northwest. At some point I went west, and then I started going southwest. The further I was going more south, more southwest west. Huh, very interesting. What can you say about my course along that? What can you say about my course along that great circle track? Was it constant? It changed. Okay, so rhumb line, okay? So a rhumb line from those 2 points, okay? A rhumb line from those 2 points, if this is 45, it would look like this. But what would that be on a Mercator, on a mnemonic chart? It would be this. That's 45. Which one of those is longer? This one or this one? Yeah, the rhumb line is a longer voyage, okay? So, but look, here's the deal. Here's the deal. I showed you a formula for calculating the distance. Boom, boom, that's the cosine B formula. And I showed you a formula for calculating the initial course, okay? All right, but do you want to like freaking be calculating? Do you want to be doing that tan C formula like every, you know, couple of miles to like get your course? You don't want to be doing that, do you? What are we actually going to do? what are we actually going to do when we plan our voyage? Here's what we're going to do. We're going to pick points at like 5 degrees of longitude difference or something like that. Points along the way. Okay? When we make a great circle voyage, we're going to pick those points along that way. And then what are we going to do with those points? What we're going to do is we're going to pluck the latitude and longitude out of that, and then we're going to plot them on a Mercator. And those points will be maybe a couple hundred miles apart. Those points will maybe be a couple hundred miles apart. Okay? Like maybe a day's run. Okay? Then what I'm going to do is I'm going to transfer those points to a Mercator chart. And then I'm going to do a series of rhumb line legs that approximate a great circle. So how much work have I done so far? I connected the 2 dots. Then I got the latitude, longitude, 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 latitude, longitude. Okay. Now what do I have to do? Now I have to do a mid-lat or a Mercator sailing between these two. Or if it's only a couple hundred miles, I could do plane. And I got to solve for distance and course. Then I got to do that again for there. Then I got to do Mercator mid-lat or for there. And then I got to do Mercator or then. Or then I got to do it again. And then, how much work is this? It's a lot of freaking work, isn't it? Am I going to do this if the savings is only 10 miles? I'm not going to do this if the savings is only 10 miles. I'm going to do this when the savings is significant, like maybe 100 miles, which is a day's run, which is time. The ship's only making money when it's offloading product that it's selling. Okay? So when it's going back and forth, it's not making money. So if you can go back and forth faster, you can get more stuff, you can transport more stuff, you can make more money. And that's the whole purpose of the shipping industry, isn't it? Piece of lint. Anyway, okay? Yeah, cool. That's a pain in the butt, but that's what you actually do. But you're only gonna do it when it makes sense. Okay? And now we're going to talk about, there's going to be things in these 2 pages, okay, 602 and 603, that tell you when it makes sense. Okay? And the exercises we're going to do are going to be teasing out whether or not you can recognize the conditions when it makes sense, when it doesn't make sense. And the Coast Guard is going to be very interested in whether or not you understand that when you take your license exam. Okay. So, blah, 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 blah. The equator, meridians, blah, blah, blah. For any other case, the difference between the rhumb line and the Great Circle connect. Oh, here's the point. Here's where we're at now. Okay. Now we're going to talk about the difference between Great Circle and rhumb line. So, the difference between a rhumb line and a Great Circle increases as the latitude increases. As the latitude increases, as the difference of longitude between 2 points decreases, and as the difference of latitude decreases, and as the difference of longitude increases. Holy crap, that's 3 conditions. Let's take the first one. Okay? Here's the first one. 1. Okay? As your latitude increases. So that means closer to the poles. The closer your voyage is to the poles, the more potential savings you could have doing a Great Circle. Okay? So let's look at number 2. Number 2, the difference of latitude between the 2 points decreases. Okay, here you go. You ready? Here's point 1. There's point 2. Here's point 1. Here's point 1. Here's point 2. Those 2 lines are about the same length. I'll bring this over here to make them so okay. All right. Those two lines are about the same length. Those 2 points are about the same distance apart. One of those, though, potentially would give you more savings as a great circle. Would it be A or would it be B? What does statement 2 signify? As the difference of latitude, that's little l. As the difference of latitude decreases. What does that mean? Little l is smaller. What does that mean? It means more east, west. The more east-west your voyage is, the more great circle. Okay, that's another variable. If you're north-south, hey, check it out. Patrick, a meridian. What is it? Is it a great circle? Is it a rhumb line? And a rhumb line. It's both. So if I'm going north-south, is there any difference between my rhumb line? No. When I'm going north-south, there's no difference. Okay? So as I get away from the equator and I start doing a voyage that goes a lot of east-west, man, that is going to be some significant savings. Now, what's 3? What's 3? As the difference of longitude increases, as D low gets bigger, what does that mean? As the voyage gets longer. Okay? So, number 1, when I'm near the equator, how come when I'm near the equator, there really isn't much savings? Because the friggin' equator is a damn rhumb line. So if I'm near the equator, I'm pretty much doing a rhumb line anyway. Maybe not, I might like 10 miles. Who gives a crap? I'm not gonna do all that stuff for that. Okay? What happens as I get more towards the poles? Well, you see the longitude line starts to skinny up, so I can change longitude very quickly. Ooh, that's nice. Okay? So as I get more towards the poles, as I go more east-west, as my voyage gets longer, I get more savings. So looking at the Earth, here is the Atlantic. Here's the Pacific. Which one, the Atlantic or the Pacific, is going to give you the greatest potential savings doing a great circle? Why? Because it's so much wider that you can have much longer voyages. But let me tell you, you can certainly do great circle in the Atlantic too. Okay? That is a clutch little 3 points right there. You're going to be asked questions on that, okay, on your Coast Guard exam. Okay. It becomes very great for two places wide. For those of you on the camera, the globe just fell on the floor. It becomes very great for 2 places widely separated on the same latitude, far from the equator. Okay? So that is going to be sitting right there in the book when you're taking your Coast Guard exam. I hope you remember this page. Yes?
So, Captain, in theory, doing a great circle across the Atlantic would save money, but is it really ever done?
Yes, it is done. I did it. I did it regularly when I was on a container ship. I was second officer. I was playing great circle routes crossing from France to Jamaica, Jamaica back to France. And I started with a mnemonic chart. I snapped it across. I plucked off at 5 degrees of longitude. Okay. And then I took those intermediate waypoints. I transferred to a Mercator chart. I plotted them on a Mercator chart. I calculated the freaking distance and the course. I put that into the freaking voyage plan. Oh my God, it was so much freaking work, but it was worth it. Okay. Because by doing that, I got to keep my job. Okay. The company wanted me to do it because we were going to get to the next port a day earlier or half a day earlier. Okay. All right. But it was worth it to me because they told me to do it. If I didn't do it, they would have fired me.
Are there like the North Seas though that you have to kind of worry about? That's what I was kind of getting at, like all that adverse weather.
Well, so we haven't gotten to that part yet. Okay. So there can be limiting latitudes. So let's talk about that for a second. Okay. What if we're doing this voyage from here to there, and it turns out that there is ice right there. There's ice right there. And our voyage plan takes us right through the ice. Well, what are we going to do? Or there's the freaking Aleutian Islands right there. Or there's a freaking North Atlantic low right there. Well, we might have a limiting latitude. We might have a limiting latitude that we don't want to go above. And that is going to be the thing we'll talk about in a few minutes, which is called composite sailing. And that's where composite is two materials put together. And so in this case, composite sailing is two sailings put together. Great circle and parallel. Right? So like, let's say, we decided we didn't want to go above 41. Well, I could great circle out to 41, then I could parallel sail, and then I could great circle again. And I would do longer than this, but of course I wouldn't run aground or get my boat sunk. So at the end of the day, I'd be ahead of the game. That's called a limiting latitude. Okay? All right. Are you ready? I think that's pink. Yeah, it's going through my head these days. Anyway, so a great circle is the intersection. Oh, I discovered that driver's license song the other day. Oh my God, I love that song. It was on freaking SNL. I never heard it before. I said, I love that song. Oh, it almost brought a tear to my eye. Anyway, okay. The driver's license song. Olivia Gordon or Montenegro or something like. I don't remember exactly her name. Rodrigo. Olivia Rodrigo, I think. Yeah. Wow. I was like, whoa. So I said, Alexa, play me songs by Olivia Rodrigo. I was like, oh. Then I added a couple more songs. I got a playlist called Girl Rock. I got a playlist called Crush, and a couple of her songs made it onto both of those lists. Wow. Yeah. Oh yeah. So anyway, a great circle, people, get focused for God's sake. I don't know what the hell you're talking about around here. A great circle is the intersection of the surface of a sphere and a plane through the center of the sphere. Cuts it in half. That's what that says. It is the largest circle that can be drawn on the surface of the sphere. It is the shortest distance between 2 points along the surface of it. We've already talked about all these. There it is right there. Okay? Now let's go to the next page. Boop. Okay. Now, it is the shortest distance between any 2 points on the sphere. Any 2 points are connected by only one great circle unless they are antipodal. Antipodal means 180 degrees apart. Let me ask a question. Okay, Justin, if your vertex is like 50 degrees north, here's my vertex. Okay, so here's the prime meridian. Where is the freaking prime meridian? Oh, I'm in the wrong hemisphere. Here's the prime meridian, Justin. My vertex is right here, 50 degrees north. Where's the vertex? Is there, so how much, let me ask you a question. That vertex, is there another one on the planet? Where is it? It's 180 degrees of longitude opposite, and what's its number? If this one's 50 degrees north, what's the number in the south? 50, okay? Remember that. Let's see. Tyler M. If I am at my vertex at the prime meridian, how many degrees of longitude is it until I cross the equator? If it's 180 degrees from here to there, how many degrees do you think it is until I cross the equator from the vertex? It's 180 from there to there. How much is it going to be? If it's 180 from there to there, how much is it going to be until I cross the equator? 90. Yeah, 90. Cool. Yeah, 90. Love it. Okay. Every great circle bisects every other great circle, thus except the equator, every great circle lies. Every great circle other than the equator lies half in the northern hemisphere and half in the southern hemisphere. Okay? So, oh my God, this thing is just a mess. But, here's, where is it? Oh, here it is. My God, you can't even see this thing. But here it is. Here's this great circle. Okay? Half of it's in the northern hemisphere and half of it's in the southern hemisphere. Okay? And what's the maximum latitude called? Vertex. Okay. All right, great. Any 2 points? Okay, now there's some funky stuff. I just want to cover this. I gave you a handout. Okay, I'm not going to linger on this too much. Actually, I got a slide that'll do it. We'll come back to that. Okay. Any 2 point? Don't want to do that. Okay. The points of greatest latitude are called the vertex. For each great circle, there's one in each hemisphere 180 degrees apart of longitude. At these points, the great circle is tangent to a parallel latitude, and hence its course is either east or west. Can't be both simultaneously because you're only going, you'd have to explode to go both ways, okay? All right? So don't do that, okay? But you're either going east or west when you cross, when you're at your freaking vertex. Okay. On each side of these vertices, the direction changes progressively until the intersection of the equator is reached 90 degrees of longitude away. That was the answer. That's the question you just answered. Where the great circle crosses the equator at an angle equal to the latitude of the vertex. Okay, so on the handout that I gave you last class, okay, the last page, towards the back of this handout, there was a little, oh God, there it was again. Okay, it's page 7. There are these little exercises. I'm going to give you one of these on the next test. Okay, and it's like, okay, so this sentence right there tells you how to do that. If my vertex is 50, okay, here's my vertex. All right, my great circle goes like this. Okay. All right, so there, let me draw that again. Let me draw that again. Okay? If this is 50 degrees north, the angle of the vertex is equal to the angle between the great circle and the equator. So what does that mean? That means that this angle, if this is 50, that this angle is 50. It also means that this angle is 50. That's cray-cray. That is cray-cray. Okay, if I know that this angle is 50, Oscar, if this angle, that is east, when I cross the equator, the angle between the equator and my course is 50 degrees. What am I steering as I cross the equator? This little worksheet that I gave you is going to be little examples of this. You're going to have one of these on the next test. So it's 50 degrees of angle right there. North is here to 90, and then it goes on to there. What am I steering? 140. Okay? Cool. What if I was going in this direction? Okay, Rebecca, I'm going in this direction.
310.
Okay, so yeah, you could do 360 minus 50, or you could go 270 plus 50. I think it's 320. Or no, it's not. You can't do this. Okay, because this would be, this angle here is 90 minus 50, so it's 40. So you got to be careful.
320, so if you add it.
Yeah, so you could subtract 40, or you could add 50. Okay, that little handout, that little page 7, there's a number of little examples of that. We'll do one more and then we're going to move on. Okay, here we go. My latitude of the vertex is 40 degrees north. Okay, so let's say I'm going in the westerly direction. Okay, I'm going in the westerly direction. Sam, the angle between the equator and my great circle, if this is 40, what's that angle? It's 40. The angle between the equator and the intersection of the great circle is equal to the latitude of the vertex. So that means that this one's 40 and this one's 40. So you got to watch out because that one's not the 40, that one's not the 40. Okay? So here we go. Here's north, and I am steering this course. Okay? If that's north, I'm steering this course. So as I cross the equator, what am I actually steering by the compass? What's that? 180. Now, I can do, so if this is 40, what's this one? Well, that's 40 minus 50. That's 40, 90 minus, anyway. The thing to do, there's a couple different ways to do this. I can figure out this angle. So if that's 90 and that's 40, that makes that 50. So it's plus 50, okay, which would be 230. Or I could say that's 270. and that's 40, so it's minus 40, and that is 230. Okay? There's two different ways you can do that. I'm going to ask you one question on the next test to do that. That's there, the key is posted, off you go. Okay? All right, let's see what else this thing says. On each side of the vertices, direction change progressively to the as the great circle crosses the equator, change in the which region. Okay. On a Mercator chart, a great circle appears as a sine curve extending equal distances each side of the equator. Yeah. The Rhumb line connecting any 2 points of the great circle on the same side of the equator is the chord of the curve, meaning a straight line near the equator. La, 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 la. I don't even care about the rest of that paragraph. Okay? Let's go to this. Now, we're on page 603. That was the top of 603. This is the bottom half of 603. 2 points on the same meridian are not joined by that unless the 2 points are equal. If they are poles, the meridians pass through them. Every great circle bisects every other great circle. Thus, except for the equator, every great circle. Did we already do this? Did I go the wrong way? Oh, this was the last. Was that the last? Have we done this yet? Okay. Oh God. Okay. Great circle is used when it is desired to take advantage of the shorter distance along the great circle between 2 points, rather than follow the longer Rhumb line. Now, if it's only 10-mile difference, it ain't worth all that work. But if it's 100 miles or 200 miles, it is worth all that work. The arc of the great circle between 2 points is called the great circle track. Okay, so what does that mean? Hey, check this out. I could do a great circle from like here, from Lima to Auckland. Okay, all right. So I could do that great circle, right? But am I doing the entire great circle? I'm doing a segment of a great circle. So there is a great circle that goes all the way around the earth. There is no great circle you can actually go on and go without running aground. So you can never, ever do an entire great circle on a boat. You can only do it on an airplane, okay? Or if you run really fast, you can like skip on the water or something like that, you know, like a cartoon character, you might be able to run, okay? But there's a lot of ups and downs too, you know, anyway, you don't want to do that. Better in a plane. So we never do an entire great circle, we do a segment. We do a segment. Yes.
Planes fly on great circle tracks?
Yeah, they do. Planes will do a lot of that, you know, particularly because like when you go from New York to like Japan, they go up and over because that's shorter.
Do they actually get that close to the pole?
They probably have some limiting latitudes. I don't know. It depends on the voyage. I don't know. I'm not a pilot. Don't know. Maybe. Yeah, because it's shorter. Okay. Anyway, so where are we? Oh, we're in Article 1015. So that means it's two little sections later on. That's how biology is organized. Slight depart. Okay, no. Okay. The Rhumb line appears a more direct route because of distortion. The decision of whether or not to use a great circle depends upon the conditions. The savings in distance should be worth the additional effort, which I showed you. And of course, the great circle should not cross land or carry the vessel into dangerous waters. I think, Nick, you were asking about limiting latitudes, okay? Or excessive high latitudes. A slight departure from the great circle or a modification called composite sailing, that's Article 1017, 2 seconds from now, okay, may effect a considerable saving over the Rhumb line. So the Rhumb line wasn't so good. The great circle, I was going to die. So I do a great circle, I do a parallel, I do a great circle.
Do fairways usually follow great circles?
Fairways, I mean, fairways are typically where you're going to have the land. You're not going to have a fairway out in the middle of the ocean. So, yeah, so those are short distance, those are going to be Rhumb lines. Okay, those are straight. Okay, fairways are straight. And they're in places of congestion. So we typically don't have, but there are great circle routes where you'll see vessels. Okay, those are plotted on various charts. Since the great circle is continuously changing as one proceeds along, at no attempt discussion with the environmental level. Okay, all right. So that is those 3 pages. I'm going to show you a couple more things, a couple more little pictures. All right. The stuff I drew up on the board, here, this little thing here is if you want to come back and download this, all that math stuff I was doing right there. Okay. I'm doing it right. I'm doing it in the PowerPoint in theory. This freaking thing would work. Okay. So I was doing some math there. Okay. All right. And so that's in the PowerPoint, what I did on the board. Okay. So you can go back and look at that. There's 2 examples of that. All right. Bada bing, bada bang. Okay, so I drew this on the board already. There's your great circle. There's your intermediary points. All right, so what do? You get those intermediate points, you plot them on a Mercator, and you calculate those distances. Oh my God. One of the things we're always interested in is the latitude and the longitude of the vertex. Okay, so as I look along here, that is a latitude. So that's obviously the highest latitude. So that's a curved line of a latitude, right? And so the highest latitude of the vertex is going to be right around here, and that has a longitude and it has a latitude. You're going to be able to read your charts in just a minute. Where do you get your information? Well, you can use your calculator. In CNAV, you're using that book, 229. 229 is the same anyway, formula 36 and 37 are the same formulas you're using in CNAV and TNAV, they're just different terms, okay? But basically, we use D low, in CNAV you use LHA. So you just swap those 2 in the book and boom. L1 is the assumed latitude, L2 is the declination. That's in CNAV. In CNAV, that's that. In Great Circle, it's this. The distance, anyway, yeah. Okay? So I'm not even gonna linger there, okay? So, these were the 2 pages we just read. This is slightly out of order, all right? I'm just like you guys, right? I'm just barely freaking keeping up right now, okay? Barely. I was working on this PowerPoint at 4 o'clock this freaking morning, right? So anyway, all right. I woke up. I was like, oh my God, I'm not ready. I try to clean it up a little bit. But anyway, so next year will be better. This year it's just there, okay? But anyway, these 2 freaking pages, okay, these 2 pages were what we were looking at. We looked at that. We looked at that. We looked at that. Okay. This is just driving. I already drew this, but since it's in here. This is a mnemonic chart. How do I know that? Because my meridians they're all straight, but they're all converging up there and they're wide down here. And if I had latitudes, they'd be curved. I put those in at 4 o'clock this morning. I didn't have time to put the freaking latitudes in. Come back next year, you'll see the latitude lines, okay? So boom, that's the great circle. Look at that. Yokohama to Seattle goes right through the freaking Aleutians. What does that look like on a Mercator chart? Bastard. Don't make me walk over there. This is a Mercator chart. That's the Great Circle voyage on the mnemonic projected onto a Great Circle. On a Mercator. It appears longer, but it's shorter. Holy crap, maybe we don't want to go through there. If we're a tanker, you can't go through the Aleutians anymore. So now you have to set a limiting latitude, and that limiting latitude, this is 40, that's 60. Looks to me like 52 is where the Aleutian starts, so maybe your limiting latitude is like 51. So I'd love to do that, but there's a reason why I can't. Or there's a big storm up there, or there's freaking ice, which you get more over here. Anyway, okay? So we're gonna be dealing with that in just a few minutes after we take a break. Let me just show you a couple more slides. Okay? Mercator chart, yeah, great, love it. Oh God, what is going on? Is it just the batteries dying, or is it the, I imagine the battery might be shit. No, battery's fine. Okay, so that's the Rhumb line, okay? Sorry, video people. All right, now, I'm not gonna go over any of this because I already did. These are Captain Parrott's notes. I just cut them and pasted them in the next slide. I pretty much talked about every one of these things. I just collected all those points and I just pasted them in the next 3 slides. These are highlights of what I just talked about. So you should go back and, as you're studying, you should go back and review them, okay? All right. Now we're gonna take a little break and we're gonna come back and we're gonna start working on these exercises and teasing out what's going on with this. So take 5.